Okay, let's do the third question, or the second question. So this is question 4B, and it is a police officer has 400 meters of yellow tape to seal off the area of a crime scene, which we're going to assume is a rectangle. Does it say that? Yeah, rectangular area. Okay, so they actually give you the equation in this question. It's negative x squared plus 200x. But just to quickly show you how they get that. So the police officer has 400 meters of tape. So that 400 meters has to go around all four sides. So the total perimeter of this rectangle would equal 400 meters. Which also means that if you were to split this in two, like just a length and a width, the length and the width would have to add up to 200 meters, right? Half of 400, because that's half the rectangle. So in the question, it says that x is actually the width of the crime scene thing. So x is the width. And if we wanted to represent the length using the same variable, because you don't want to introduce a billion variables, then we could say that the length is 200 minus x, because like we know both of those blue sides have to add up to 200. So that's how we could do it. And then what they did to create the equation is they just made an expression for area. So area equals length times width. So we know our length is 200 minus x, and we know our width is x. And if we were to just expand that, we would get negative x squared plus 200x, which is the exact equation that is given to you. So you could have actually come up with the equation yourself if you wanted to. All right, so let's solve it. It says, what is the maximum area that can be enclosed? So we're trying to find the max area of this shape. Okay, so what happens is if we checked out a graph of it, we've got area being graphed and the width, which is our x value. So, as you increase the width, the area it's going to function like a parabola. We know the y-intercept is 0. So we know the parabola is going to look like this. So we're looking at the area that is maximized. So that's going to be our max area right at our vertex. And the width is going to be some value. So again, since we have the word max, we need to complete the square or partial factor. In this case, I'm going to partial factor this one because we have no y-intercept, so I can actually just set 0 in for the y value. Negative x squared plus 200x. So I'm partial factoring to get the vertex. Okay, so next step in partial factoring is to common factor. So I'm going to factor out a negative x, which will leave me with this. So I just common factored. And then I'm just going to set each of these terms equal to 0. And then I'm going to solve for x. So in this case, x is just equal to 0, which we did already know that. And then over here, x is equal to 200. Oh, wait. Okay, I'm sorry if you're listening there. I didn't mean to put that dot there. Oof, I'm tired. Okay. So we actually, no, that is that. That is actually 0, and that is actually 200. Because 200 is our biggest width. That does make sense. Because 0 was the value that we subbed in for our area. So this is y equals 0. Okay. So anyways, we're finding the vertex. So we found 0 and 200. So now we're going to find the midway points, which is going to be 100. So 100 is going to be the location of our vertex. And then if we wanted to know our max area, we could just sub 100 in for x. So we'd have negative 10,000 plus 200,000 or 20,000, sorry. Which would equal 10,000. So we know our maximum area will be 10,000 meters squared, and our width is 100. So the question asks, what's the maximum area that can be enclosed? So the maximum area is 10,000 meters squared.